guys, in this video we're just going to extend ourselves in terms of Venn diagrams and how we can display it to two-way tables. Just kind of revisiting the whole notion of intersections and complementary events. So the complement of B is anything that doesn't happen with B. And we've got event A, we've got event B. Basically A is all the students who study art, and B is all the students who study biology. And then obviously the overlap in between are the students that study both art and biology. And anything that happens or exists outside of those two circles are those who don't belong anywhere. So here we could say that there are 3 students who study art and nothing else. We have 7 students who study biology and nothing else. We have 2 students who study both art and biology, and we've got 8 students who study neither art or biology. Then we could say, well, how many students study biology? Well, it's the 2 plus the 7, which is 9. And how many people study art? Well, it's the 3 plus the 2, which is the 5. Okay, so just to recap, so if we have the A intersection B, okay, so then we're looking at, this part here, okay? So that's going to be equal to 2, okay? And then if we wanted the, say, A intersection of anything that is not belonging to B, okay, then what we're actually looking for is this section here. Okay, so it belongs to A, but it doesn't belong to B, okay, because this 2 belongs to B, that 7 belongs to B. We don't want that, we want to exclude it. So that is going to be equal to 3, okay. So A, 3, and 2. If we wanted, say, something that is not A, but intersects with B, then we're going to obviously look at the opposite. We're wanting everything that belongs to B and doesn't belong to A. So in this case, it is 7. Hopefully this is making sense at the moment. And so we'll take this out. So B is 7 here. And then lastly, if we were to look at everything that doesn't belong to A and doesn't belong to B, that's going to be everything on the outside. Okay, and that number is 8. All right, so on the right-hand side, we've got a two-way table, and these values here actually help us with this table over here as well. So think of your timetable book, timetable chart that belongs at the back of your exercise book, and you would have a grid. Okay, you would have the tables 1 to 12 on the top, tables 1 to 12 on the left-hand side going down, and everything that is that crosses over or intersects with each other is what those two things are multiplied with. Okay, so let's have a look at this grid on this right-hand side, our two-way table. This box here is the intersection of A and B. So A and B is 2, okay? And the intersection of A and not B, so those students who only study art, okay, is going to be 3, okay? And those who study biology and not art is going to be 7. And those who don't study art or biology is going to be 8. Okay, and as you look at this, on the right-hand side, we've got a tally, which is kind of like the total. And you want to make sure that it makes sense and it matches everything that's in the table here. So if I were to ask you how many students study biology, we could see in this diagram, 7 plus 2 is 9. And we want to make sure our numbers match. Yes, they do. 2 plus 7 is 9. And the number of people who study art altogether is the 3 plus 2, yep, equals 5. There are 5 students that study art. And then how many students do we have in total? Well, we can have a look at these things here. So, well, the 7 plus the 8 is going to equal 15, okay? And then the 3 plus the 8 is going to equal 11. So you can see how we need to have the total going across and also going down. This last box at the bottom, we need to make sure that these two numbers add up to the same total as these two numbers. 5 plus 15 is 20, and 9 plus 11 is 20. So we have 20 students altogether in this diagram studying art and or biology. So that's just a quick snippet just to show you how to display one from the other, and hopefully it helps. Any questions, let me know. Also, I'll see you in the next one.